Pinguberry team, and we're going to present a project inspired by the movie Coraline.
Hello, I am Giovanna and I made the software.
Hi, I'm Catarina and I made the hardware.
The project consists of 5 robots and 2 main software systems. Here is a brief summary of our presentation. Now, we will present the 4 main features in greater detail. Coraline's electromechanics is our first feature because we aim to make an animatronic that emulates a human. What is innovative about this feature is that we have used different components, materials, and mechanisms in a creative and unique manner. First, its electronics was designed to support many servo motors and also lots of circuits being powered simultaneously. A 12-volt battery is connected to a switch and to a fuse box, which are usually used in the automotive sector, and it was chosen because it allows the creation of several independent power supply circuits and in a safe manner. The circuits attached to the fuse box are power for Raspberry Pi 4 and 5, the power supply of Arduino Uno and Mega, 2 BTSH bridges, and the power supply board for the servo motors. The board is made of phenolate material and it was produced by us with tin traces. The board was designed to be as safe as possible because it's going to power around 20 servo motors. Therefore, we used 2 voltage regulators and capacitors to ensure the stabilization of the circuit. Coraline's mechanics was designed in such a way that all of its movements resemble the fluidity of a human being. Its structure is composed of PVC pipes, 3D printed parts, and a wooden base. Furthermore, the arms have 6 servo motors and 2 articulations each, at the shoulders, so that it can perform the movements of raising the arm, and at the elbows, where there are 2 servos performing 2 different movements, the vertical and the horizontal. There is the eye mechanism, mouth, neck, and legs. Finally, Coraline's electromechanics is present in the performance when it receives a signal that will trigger several reactions, such as waving, programmed through functions that simultaneously alter the position of all servo motors in the Arduino.
Our second feature is the Unity as an extension of the stage. This feature is used on the presentation in the game engine in Unity, which is going to be connected to the big screen and function as a dynamic and interactive digital extension of the stage, represent Coraline's visions of the other world. It was chosen as this feature because it represents the transition from the real world to the other house, being an integration between art and technology. What is innovative about this feature is that the virtual environment is responding in real time to the robots and the other mom's movement. It is an active role in the presentation rather than a simple visual effect. It would be similar to a VR glass, showing real time the other house and the other mom through Coraline's perspective. We developed an app using the SDK AR car, capable of estimating the cell phone's position in real time, combining the images from the camera with the internal sensors of the cell phones. The coordinates are going to be sent via Wi-Fi to the unit, which uses their virtual camera that is responsible for the Coraline's vision inside the 3D environment. This virtual world recreates the magical atmosphere of the other house. That's the reason why we used 3D backgrounds with dynamical elements, animations, and visual details, such as shaders and particles, which highlight the idea of a living world. Our third feature is image recognition as our tool to make the project autonomous. What is innovative about this feature and why we chose it is because it enables the robot's dynamism, integration, interactivity, and automation. We use this tool in 3 different ways. The first use of this feature is when one of the characters shows a little Coraline marker to the computer connected to the big screen. We have used the game engine in Unity and the Devufora SDK to make it recognize an object, the marker, and send a Bluetooth signal to all of the robots indicating the act of the presentation as a counter. That is an innovative way to trigger the robots. The other 2 types of image recognition on the presentation are on the 2 Coraline Raspberries. On Pi 5, it detects a green boot and the robot follows it. On Pi 4, it recognizes different objects, triggering specific functions. Both of them were chosen in order to make Coraline sensitive to its surroundings and humans. During the development, we are in touch with the creation of an AI from the beginning. We created an image dataset of the objects, classified them, and trained a customized object detection model with YOLO V8N based on instructions of Google Colab. In terms of coding, we use Python, especially with the library OpenCV to filter the images and do the inference to the model. Concluding, on Pi 4, shards are sent to trigger the Coraline's reactions depending on which object was detected. On Pi 5, depending on the position of the boot in the camera, Coraline is going to follow its direction. The fourth feature is the piano as a living being. We choose this feature inspired by a scene from that movie, which made possible the addition of a complex technology. What is innovative about this feature is that we transform an object theoretically alive into something capable of feeling, interpreting, and playing music. We use the technology to emulate the way a human plays a piano, reinforcing the illusion of a living being.
Regarding hardware, the piano uses a 3D printed style mechanism with 2 moving carriages in order to reach both the white and black keys. Each carriage has 3 servo motors that emulate a pianist's finger using linear mechanism to press the keys from above the piano. We chose stepper motors for their high precision, and we calculated the relationship between real-world distances and the number of motor steps needed to reach each piano key. To allow those carriages to move independently along the rail, we used 2 stepper motors, each with its own pulley and belt system, enabling simultaneous movement.
In terms of software, we organize the song's notes in a vector that represents its chord and has information such as duration and pauses. The servo motors use this information to adjust the time of movement element used in its angulation. That allows the piano to reproduce pose, rhythms, and duration, making it interpret the music. Finally, we develop an algorithm that determines the most efficient finger to play its note, by considering the upcoming notes and minimizing the required displacement.
The piano's electronics were inspired by Coreline's. This diagram shows how the system works, including the step-up voltage regulator used to power the motors and increase their speed. In the movie, the piano is meant to play the other father. To recreate this effect, we built external hands using a scissor lift mechanism, making them appear to emerge from the piano. We also created an articulated robot of the father, integrated to the piano. Regarding sustainability, the father robot was built entirely from PVC pipes and reused 3D printed parts, making it a fully sustainable robot. In addition, we used PVC pipes in Coreline's structure and repurposed the breakfast tray as the base for the electronics. A challenge we faced was powering the Raspberry Pi 5, which is very sensitive to its power supply. To address this, we built highly reliable custom cables. Additionally, since our team has only 2 members, strong teamwork and careful planning were crucial throughout the project. Here's a diagram of the communication system. To sum up, here's the evolution of the project.
Thanks!